Welcome to the presentation. Good morning, everybody. We are Team 3. We are the Bop-It group, and we developed an Android-based application that mimics the Bop-It game from the early 90s.
Alright, so our Bop-It game is based on the game from the 1990s, Bop-It, it's shown right there. The original Bop-It had the 3 commands: to pull it, twist it, and bop it, and then as it evolved, they came up with Bop-It Extreme, and that has 5 commands. So we kind of did ours similar to that. We did commands on an Android application that basically simulated the game of Bop-It. The commands are many of the different in-game actions. It has a high scores menu that lets you keep track of how well you did compared to anybody else that might play it on your device, so you can kind of have bragging rights. It has single player or multiplayer, so you can play by yourself, or you can play with another person, or you can play with up to 4 people if you want. And that includes a pass it command that lets you know that you have to pass it to a different player, and changes the rate, so it makes it difficult as it keeps going. And it's a pretty fun game for everybody. So these are our team responsibilities. I'm Jesse. I was in charge of all the command actions and determining if the user got the action correct or not.
I'm Chris. I was responsible for designing the user interface as well as ensuring that the application worked well on as many devices and screen sizes as possible.
And I'm David. I worked on the audio and the synchronization of the commands to the audio.
So, going into this project, my part was kind of tough, the user interface design, because I hadn't taken any formal education with Android. The only experience we had was a little project in a previous course. So I had to do a lot of research when developing my different views and interactions that the user had to go through. One thing that really helped me was Google has a developer site that gives you not instructions but suggestions on how to design views and how to go through different views and just the best ways to present the user with information. I was able to use some previous knowledge from my software engineering languages and tools class with Professor Cool that he showed us and explained to us model view controllers, and that's how I did use the views, which all have an associated Java view to handle the user interaction. So the biggest challenges that I came up with doing the user interface was it was time consuming because I had to basically learn as I was going along, and I ran into a problem with communication between certain threads that I had to learn and handle with. The multi-device support, I thought at the beginning of the project was going to be the most time-consuming and hardest part of the project, because I assumed that we would have to do different user interfaces for each screen size and each different Android API. But that was not the case. Through Google's developer information, you can use certain relative layouts, and there are certain sizes for buttons called DP units that automatically resize based on screens and different densities. And we also, Google is very good at hosting information on what kind of devices are supported in their App Store. So every month they post a chart like this that tells you the different distributions of the APIs that are logging into the Play Store, so you can accurately design your apps to support as many as possible. We decided to support APIs 10 through 19, which gave us a coverage of over 96% of all Android devices that log into the Play Store.
So I did the commands. This is our command screen. Basically, this is the actual game view where you play the game. So there's only 2 commands that you see there, but the other 3, I guess 4 commands are just kind of there too. You just don't actually see them on the device. So each command, push it, that's kind of self-explanatory. It requires you to push that big purple button in the middle in order to trigger correct action. Slide it requires you to slide the bar at the bottom. You have to slide it over 90% of the way in order to trigger correct action. Shake it requires you to shake the device. Flip it requires you to flip the device over, so if you're holding it like a normal phone, you have to just turn it upside down. Shout it requires the user to shout into the device, and that one triggers a correct action, you have to shout at a certain level, a certain amplitude level. So what we did there was capture how it runs 14 times each time to get the amplitude, to get the max amplitude each time, and the first 4 are thrown out because that's when the command is still being said, so it gives you a shaky reading. It can kind of trigger it that it's always right. So we threw the first 4 out, and then the next 10 times that it samples are where you're available to process. And each time the beat speeds up by 5%, the amount, the amplitude that you have to shout into the microphone decreases by 5%. Otherwise, as it keeps going, it's almost impossible to yell into the microphone to trigger a correct response. You'd have to like scream at the top of your lungs. I guess I didn't mention for Flip-It. So Flip-It, it's based on the orientation of the device. So when the device is flipped upside down, that corresponds to an orientation of 180 degrees. So what we did there is I just basically did an orientation event listener, and that just detects whenever the device's orientation changes. And what we did for the boundaries there is as soon as the orientation is either greater than 160 degrees or less than 200 degrees, that's a correct response. So we gave some wiggle room there, otherwise it'd be too difficult. And then I guess I didn't really mention for shake it either, so you just have to shake the device a certain level. We didn't make it so you have to barely shake it, but we also didn't make it so you didn't have to be throwing your phone and risk trying to like drop it in or break it or something like that. And then pass it really only comes up for multiplayer, so that just says pass it and gives you some time to pass the device on to another player, and that increases the beat. The rate increasing too, it happens after every 5 commands for single player mode, and I guess for multiplayer mode. So the beat will always change and increase 5% to what it was after 5 commands. So the more you go, the harder it'll get. So for the commands, we implemented many different features. For Shake It, we use the built-in accelerometer that determines how fast the device accelerates. So that's basically a standard unit. I think we ended up doing greater than 7, so I'm not sure exactly what it goes up to, but the higher the number that you require to get to is the harder you have to shake it. So we did somewhere in the middle. Flip-It uses the sensor manager. Like I said, it tracks the orientation of the device. Like I said, I used an orientation event listener and basically just stored it into a variable that I could use whenever I wanted it. It just constantly checked the orientation of the device. For error checking too, for that also, we made sure that when you get a different action, you can't have the device already flipped upside down and kind of like cheat the game. So if the device is upside down the whole time, then you won't be able to hit any other buttons, and then you'll just lose. For Shout It, like I said, we use the microphone, and I kind of explained how we process a correct response there. And with all these commands, if you have a certain time allotted and it's based on the beat and how fast the rate of the beat is going, you have a certain time allotted. As you continue to go and the beat gets faster, you have a smaller window to answer these correct commands. So if you do a different command, so if the device tells me to push it and I sit there and I shake it, as soon as I trigger would be the correct response for the shake it, that's going to trigger an error because the command was actually push it. And likewise, if you don't answer within the time window, that's also like a timeout and you lose there too. And then your game score would just be recorded and you have the option to play again. So we did plenty of error checking and made sure that you're pushing the right command or doing the right action, and you have to also do it in a certain amount of time. And if both of those, or if either one of those aren't true, then you get a wrong answer and the game is over.
The final segment of the project was the audio, so the background beat and all the commands you hear and the different hints that you made the correct answer / incorrect. So to create that, I used Apple's GarageBand. And so in there I created a short beat with a drum kit, and I'm looping that over and over again to create this long beat that we were using and then manipulating with the rate factor. I also created a transition audio that allows the player to know that the speed is increasing or that they need to change the player. And then for the commands actually in the game, like say it or the push it, press it, actually the same thing. Slide it / shake it. I used the terminal in Mac to use the command. I can't talk. Sorry. To use the command say, and to play all the sounds, I used Android Sound Pool Service, and this allowed me to load in all the different audio files, so I can just play them at will. And then every 5 commands, the rate increases by 5%. So for the synchronization of the commands, I use a scheduled executor service, so I can schedule each event one future task at a time. So this ended up using Java's timer class, and so I created a timer task for each event. And in the timer task, it actually has a random command that they use. And then the time between the commands also changes with the rate of the beat. So this is factored in by the 5% that increases. And that's pretty much the gist of that.
So that is the end of our presentation. We'd be happy